Hello everyone, welcome back to Array Blog once again. In the previous video we learned SQL joins and now today we are learning something even more important, that is database relationship, right? So relationships are the foundation of relational database because in real world application data is connected. For example, one user can create many posts, one order can contain many product, one teacher can teach many students. Without relationship, real application cannot be built properly. So today we are going to learn one-to-one relationship, one-to-many relationship, many-to-many relationships, foreign key, cascading, referential integrity, and this is one of the most important backend concept. Now the question is why relationship exist. So suppose you are building Instagram. So should we store user, post, comments, follower inside one use table? No, that become messy, duplicated, hard to manage. Instead, we divide data into separate tables and then connect those tables using relationships. And this improve organization, scalability, performance, data consistency. Now comes the foreign key. So before relationship, we must understand foreign key. So a foreign key basically is used to connect two tables, right? So let's create a foreign key tables. So first thing what we're going to do, we are going to drop all these tables so that we will create the new one and then you guys can understand, right? So let me drop all these tables, right? And we'll close this. Now we are going to create table. First table is user and the second table is the post table, right? So we'll open the query tool, delete this and so save. Yeah. Now we'll say create table that is going to be users, and then we'll say ID serial key. Okay, so it will be serial primary key, right? And then we'll say name that is where care that is going to be 100, right? Now we'll create the post table. So we'll say, let me just copy this, Control C, Control V. This is going to be post ID serial primary key, and then type this will define as a title, and we'll add the comma here, and then we'll say user underscore ID int references users ID. This we have used before, but at that time I've just only said that this is used for connecting two tables, right? And this is your foreign key. So the important line is this int this one, the user ID int reference user ID. This means this user ID comes from the user tables, this user tables, right? And user ID must exist the users dot ID, right? And this creates a relationship. So the question is why foreign key are important, right? So that basically the foreign key help us to prevent invalid data. For example, if user ID equals to 100 does not exist, Postgre will reject it, right? This maintain data consistency, right? So let's execute this first. Okay, so we have to write table. This is also going to be a table, right? And we'll execute this. Ref, it's a references, right? So we have missing E, and then we'll execute this. Not successfully executed, and when we press this, we got post and users, right? Now we'll open another query tool, right? Now the first thing we are going to see one-to-one relationship. One-to-one means one row connect to exactly one row, right? For example, user is connected to passport. One user has one passport and one passport belongs to one user, right? So we have created the user tables that contain int name, and we are going to create another table. Just delete this, that say, we'll say here that is passports, right? And the serial key is okay, and then this will become passport underscore numbers, right? And we will create the user ID, the same thing again, user ID int unique references users, and then this will become ID, right? This will become user ID, right? Now we'll create the table. We have successfully created the table, and once we refresh this, we'll got the passport, right? Now the important concept is here, it is unique. This ensure one user cannot have multiple passports, right? So the real use of one-to-one relationship that is used in, that is user profile, passport system, employee detail, account settings, right? And then there comes one to many relationships. One to many is the most common relationships. One row in a table can connect many row in a table B, right? So suppose we have a table 1 A and table B. So one table can connect table one row can in a table A can connect many row in a table B, right? So we have a users, we have table users, and we have a table post, right? Now we are going to insert that value. So let's insert this. So let me just create this. I'll say insert into users, and this is going to be name, and then we'll say values, that is going to be array block. This will be the single quote, right? This I'm going to insert, and we have successfully insert. So we'll write select asterisk from users, right? And when we click on this, we got primary key and the usernames, right? Now we are going to insert them, insert into post, right? So we are going to insert, that is title, and then we'll say user underscore ID, right? So title we can write learning SQL, and this we can say one. We just control X, control V, right? And we can say this to one, and we can say also learning, right? And we'll execute this. It is giving us error because okay, we are inserting in a users, we have to insert into the post. When you execute this, it got executed. So when we select asterisk from post, and when we execute this, we got learning SQL, learning read, right? Now one user has many posts, right? You can see that the user okay, let me just delete this, and we'll say select users, right? And then when you click on this, we got, you can see there is a one user, that is array block, and it is associated with the post, that is basically this user has a many posts, right? So one to many exists everywhere. For example, user to post, customer to order, and teacher to students category, right? This is the most important relationship, right? Now comes the many to many relationships. Many to many, basically many row connected to many rows, right? For example, student connected to course. One student can enroll in many courses and one course can contain to many students. So the problem, we cannot directly connect both tables, so we create a junction table, right? So okay, so let's create three table first. First the student table, the second is course table, and then fourth is student course table, that is junction table, right? And then we will connect all these things and then we'll get the data, right? I'm not going to insert that values, I'm just going to tell you how to do that. So let's say create table students, and this is id serial key, serial primary key, right? And name, that is going to be varchar, that is going to be 100, right? This is our student tables, and we are going to create another table, that is say create table table create table courses, right? And now we are going to say here that is id equals to serial primary key, and then we'll say course underscore name varchar, that is going to be 100, right? Now we'll create another table, that is junction table. So we'll say create table, that is student courses, and we'll say student underscore id int references students, it's going to be id. And let me just copy this, I'll explain what I'm doing here. So we have added the student, now see your course underscore id, and this is going to be courses id, right? And we will create a primary key here, just delete this. So we'll say primary key, and we're going to say student underscore id comma courses underscore id. So this table is connecting these two tables, right? So let me explain why junction table exists. Because relational database cannot directly handle many to many relationship, so we are solving it using the third table, right? For example, the students connect to the multiple courses, user can have a multiple roles, and product can have a multiple category, movie can have a multiple actors, right? That is what many to many relationship is. When we execute this, we got, so okay, we got the, okay, we are getting an error. Let's say create create, let me add the comma. I don't think so, that is because of semicolon. We'll execute, yeah, it's because of semicolon, right? So we have created three table, and all these two tables are connected to this tables, right? It is store the id of student in in the student courses. It also is to store the courses id in a student courses, right? And then we will get the value using all these things, right? Now comes the next topic, that is cascading. So the cascading is suppose a user is deleted, should all related posts remain? And the answer is usually no. But we want related record to automatically delete it, and this is called cascading, right? So suppose we have a post, it will say view data, right? We have all this data, and we have created right now we have created this without cascade tables, without cascading, right? Because it contain the data learning SQL, React, and user ID, right? When we create the table, the post table, using the on delete cascade, then basically what happened, let me write. I'm not going to write that. I'll just give you the query things how things will become. So we'll say create table, that is post, and then we can say ID serial key, serial primary key, title, that is going to be varchar, that is 255, and then we'll say user underscore ID int references user underscore ID. This is going to be users underscore ID, and then we write on, you'll write on delete cascade, right? So what happened now, if let me tell you this. Yeah, if the user this users if this user got deleted, then whatever the value that we have inserted here, right, in a post, it got automatically deleted, right? So the basically when we want user is deleted, we want all the row and all the table that belongs to all the value that belongs to that particular user should be deleted, right? That's where we use on delete cascade, and that's why we use the table. That's why we create the table like this, right? So other cascade option basically on delete cascade, on update cascade, and set null, right? So on update, whenever the user is updated, the value is updated, and same goes for the null example, right? So if user is deleted, the user ID become nulls instead of deleting all the rows, right? So the real uses of cascading is heavily used in social media apps, e-commerce, content management system, right? Now the next part is referential integrity, and this is very important database concept. Referential integrity means relation between table remain valid, right? Suppose this post user dot id post user underscore id equals to 1, right? We have 1, but the user or let's say suppose user underscore dot id equals to 5, right? But user 5 does not exist, right? User 5 does not exist, we don't have user 5. So this creates broken data, right? So let me just, you understand this, right? User ID equals to 5 does not exist, and it's created broken data, and foreign key prevent this, right? That is what referential integrity means. So referential integrity ensures no valid reference. So if you don't have a, basically you cannot enter anything in this without without relating to any user. That is what referential integrity means. Means no invalid reference, no broken relationships, consistent data, and reliable data structure, right? And real importance of referential integrity. Without referential, application become unstable. Order without users, for example, order without users, comments without post, payments without accounts, and that cause huge problem, right? There comes real project basically. Suppose you have Instagram, so relation becomes user to post, post to comment, user to followers. Same goes for the e-commerce, user to order, order to product, product to category, and same goes for the school management system, banking system. So the best practice is always use foreign key, normalize data properly, avoid unnecessary duplication, use cascading carefully, use cascading where you only want to delete that. If delete that data, if the user is deleted, that data should be deleted. Use only for that, right? Design schema before coding, how your table structure will be. So good database design is extremely important. And that's it for this video. So today we learn about foreign key, one-to-one relationship, many-to-many relationship, many-to-many relationships, cascading, referential integrity, and these concepts are backbone of the relation database. In the next video, we will learn that is a group by, having subqueries, union, advanced querying, which is where SQL become much more powerful. So if you enjoyed this video, don't forget to like, comment, and subscribe, and share with your colleague. I'll see you into the next one. Thank you.